conducting a course on AI machine learning. This will be a basic course, and this course will contain about 10 videos. This video will give the introduction of the AI and what you can expect in the basic course. AI is basically concerned with understanding intelligence in general and also building intelligent entities. There are two wings in AI. One is it wants to make machines which behave like human beings. The other is it wants machines to behave rationally, which may not necessarily be like human beings, but try to do things which look right. Within these two views, there are two levels at which AI is being considered. One is the internal thought process and reasoning. So in this case, only the reasoning and thinking level machines are being considered. But the other view is, which is more general and includes this, is to also show intelligent behavior to the outside world and interact with the external world. For example, building intelligent robots. Robots will be walking around, talking to people, taking instructions, and do other things that human beings do. For these purposes, right early in the beginning of AI history, Turing tests were designed. The basic Turing test, which was designed in early 50s, it checks if the machine behave like humans in thought process and reasoning, the first level that we were talking about. And in total Turing test, uh, we check if the machine behaves like human beings in external characterization. For example, it can be used to test if a robot behaves in an intelligent way like human beings. To pass the basic Turing test, that the first test that we have talked about, a machine to be able to behave like a human being in thought process and reasoning needs to have natural language processing abilities, to be able to understand and generate natural language, because it will have to interact with humans and other machines. Of course, it will need to have some knowledge representation. Whatever knowledge it has, it needs to store it. Whatever it learns, that also it will need to store. And how it will do that is specified by the knowledge representation that we are using here. Automated reasoning. The machine should be able to reason by itself. It should not be requiring instructions from human beings to do many things. For example, to answer questions and draw new conclusions based on discussions and so on. It should also have machine learning ability. So because the machine may not have been trained initially uh, for certain scenarios, it may have to deal with new scenarios, and it may have to reason out new things. So machine learning is required. Capabilities for total Turing test. So, which is the larger test, includes the external characterizations. The machine will need, in addition to the characteristics that are there, because it has to interact with objects and people in the real world, like the robots, it also needs computer vision. So the robot will have to see around. Suppose it has to walk like human beings. To walk, it will have to find its way, and there may be other objects in the way it may have to avoid. It needs speech recognition. It needs to be able to talk to people and to understand what they are speaking. And not only that, robots have to do certain things. For example, in factories, if robots are working, they will have to work like human workers. So they may have to move around, they may have to talk to each other, and they may have to manufacture some products in the factory. So they will have to manipulate them as well as move around the objects and fit in certain machines. Now let's talk about the agents. In AI, we talk about agents, which are some entities which act. They operate autonomously. They don't need detailed instructions at each step to act. They can perceive the environment. They will see the environment around them and then act accordingly. And they can persist in their behavior in autonomous way for long period of time. They can adapt to changes and they can create their own goals. And once they create the goals, they also may pursue those goals autonomously. There are something special kind of agents called rational agents. These are agents, they behave rationally. And what does it mean, behaving rationally? They will act in a way such that they get their results in an optimal way or best expected way in case there are uncertainties involved. Rational agents may not necessarily be behaving like human beings, and for that, the rational agent not only needs the capabilities to pass the Turing test, but also uh, using those capabilities, you can either behave in a human like behavior, have human like behavior, or a rational agent. So both things can be done by the machine if it has the capabilities given above we have provided for Turing test and total Turing test. The rational agents may have advantages over human-like behavior. So you may want machine to behave like humans, or you may want to behave them like rational agents. But rational agents do have some advantage over human-like behavior because humans can possibly behave in an irrational way, not in the optimal way to attain certain goals. Secondly, and importantly, rationality, unlike human behavior, can be precisely mathematically defined, and you can have, um, in general, uh, their mathematical models can be built. Not only that, once you can have the mathematical theory and mathematical models for them, you can design so that they will act to achieve their goals in an optimal way. So this is a definite advantage for the rational agents as compared to the human agents, because human behavior more complicated, may be not necessarily completely rational, and humans don't necessarily always behave in a totally optimal way, and mathematically modeling them can be difficult. So currently, the aim of AI are not for machines to behave as human beings, but rather as rational agents. And how do you design rational agents? To do that, the rational agents have to act optimally. Or if there are uncertainties, and often in real life, in complicated scenarios, there will be uncertainties in the states, in the acts of other people, and so on. In that case, rational agents should behave in a way so that the expected utility or reward is maximized. However, so that may be the aim. However, due to computational storage, time constraints, and other issues, you may not be able to find optimal solutions, or optimal solutions sometimes may not even be available. In that case, of course, rational agents can uh, get the solutions which may have limited rationality. It is called satisficing. Or they may opt for suboptimal solutions because optimal solution may not even exist or you are not able to find it. So you may opt for suboptimal solutions which are good enough, close to the optimal solution. However, so these are very good advantages of trying to design rational agents, but there can be challenges. In real life, we may not actually have for our purposes a fully specified model or the objectives right in the beginning for various reasons, because the scenario or system may be too complicated. You may not have, full models available to you. Only partial model may be available to you, or even the objectives may not be. For example, if the application or rationalism that you want to design is for playing chess, then all the objectives, the whole scenario, the whole model is available to you a priori, and you can design that in a mathematically uh, proven ways. But if the application is a self-driving vehicle, for example, the vehicle has to drive in the city or along different roads, then there are a lot of different things that the vehicle is going to face as it goes along on the roads. There can be other traffic coming in, people walking in, there will be red lights and so on. So those are totally unexpected things that can happen. And therefore, you cannot specify the overall model completely beforehand and define the path that it has to take at what time uh, before itself. In addition to that, even if there was a clear-cut objective and the uh, the optimal solutions, it may happen that the optimal solution may involve fatal errors. For example, in case of driving vehicles and so on, or even for a robot in the factory situation, it may take a certain path to go, but the optimal path, the shortest path, may involve other objects in the way, which can hurt it or the hurt other people. Also, there can be things like the machine may not be fully aware of the human objectives, the human who is trying to use the machines for their own useful purposes. Considering all this, the agent should not necessarily pre-specify the optimal solution and the optimal goal. It may have incentives to act cautiously. So at any time it is making some moves. So it may be need to be cautious that the optimal solution at that time available may not be the best possible way because of the risk involved. It may ask for permission also before taking its certain uh, decisions or acts, because the human beings may be able to see uh, certain scenario which may be risky, and therefore sometimes the AI agent, the rational agent, may not be able to see it. So it may ask for permission to take certain action. It may learn certain preferences through observations as it's going along, because there are uncertainties, as in the automatic vehicle, autonomous. It may also sometimes defer to human control. It may ask humans to take over. Again, the example of autonomous vehicle is there. Sometimes the scenario can be such that uh, instead of it taking action, it may ask human to take control of it. The ultimate aim is to make AI agents that are provably beneficial to humans, and also controlling super agent, intelligent agents can be a serious issue. Now let's discuss about the requirements for making AI. AI agents sometimes, so first of all, um, the knowledge that it wants to have represent, how do you represent the knowledge that it is going to use, the the model of the world that it is going to work in, its states, relations, and so on. It requires college causality also, which can be given by Bayesian networks as well as graphical models. Once you have the representation of the world, then you may have to predict certain current and future scenarios and states, which will be done by machine learning. Planning the sequence of actions to achieve certain goal. It can be via search. Search can be in different ways depending on the situation and the information available. For example, in deterministic scenarios, complicated but complicated scenarios, you may be using logic programming, dynamic programming. If there are certain uncertain scenarios, then reinforcement learning can be used. Now, we talked about knowledge, representation of knowledge, but how the AI system will acquire knowledge. There are many ways to do this. It can acquire knowledge through human experts in the domain of applications. And that used to be the scenario in the 80s when expert systems like General and Myson um, were popular. The agent can learn with time. It can learn through data available to it, that is in machine learning. It can learn using data as well as prior knowledge, so that can enhance the speed of learning. It can also learn through ongoing interaction and environment that it is facing as it is going along. That is done via reinforcement learning. Now we will discuss about introduction to machine learning and the other things, search and other things that we have been talking about. Machine learning is one of the most important things that is needed in AI agents, and it is the machine learning in which most progress has been made in recent years and also the successes. Machine learning is essential for building intelligent agents, as we just saw that its requirements in building the agents. It can be considered part of AI. It also has independent roots in pattern recognition. In 70s, pattern recognitions were very popular. A common example was recognizing objects and images, which still happens to be one of the important examples and applications in machine learning. Pattern recognition has statistical origins also, like generalization error we will be discussing when we go in details of machine learning, that is related to the statistics. There are many applications of machine learning. It has numerous applications beyond AI as well. So we will be starting our study in machine learning first, then the other things will be there. We will start with introduction to machine learning. There are many popular techniques: K nearest neighbors, support vector machines, and kernel methods, random forest. These were the popular techniques that were used earlier. But since then, in last 10, 15 years, deep neural networks have become most popular, and we will spend a lot more time on them, like 6 videos in the basics that we'll be doing. After that, there will be later modules that will be regarding basic search techniques which are needed in AI and learning using data and prior knowledge. So this will also be discussed in the basic course that we are talking about. Thank you very much, and we look forward to your participation in the rest of the course.